So I was going to give a bit of an update. I think I talked about SVI on this call. I don't remember how long ago now, but on this call I was going to provide some updates of different recommendations that we have come about sort of since the last time we gave an update, so focusing on some more concrete recommendations that have come out of the SVI over the last few months or so. All right, so the thing I was going to talk about today are briefly about the reputable source criteria, Bayes paper that we had come out, and then recommendations for loss of function and de novo criteria. So as many of you probably are aware, we have been, at least within the SVI, been telling groups or advising them to not use the reputable source criteria during variance assessment. This is the PP5 and BP6 criteria, but we haven't really had anything to point to for justification about that. But just last Thursday, I think, our letter to the editor in Genetics and Medicine came out about these criteria codes. So I have the PubMed ID up there if anyone's interested in looking at it. But overall, our main reasons for why we think that these criteria codes shouldn't be used are outlined in the paper. But they are briefly that we think, looking at primary data is better than looking at expert data without, or expert opinion without any data. So when you're looking at interpretation from another group, if you don't have their evidence, you don't know what went into their assessment. And so we think that, basing your assertion off another group's assertion is not, would not be in good practice. We're also concerned that using the reputable source criteria could also lead to double counting. So say you are using, assessment that came from an expert panel and they incorporated some functional data and called the variant pathogenic. If you're looking at that same functional study and also applying the criteria for that functional study, and then also applying that another group called it pathogenic, you are, double counting those evidence types. So sort of our overall reasons for why we think that those shouldn't be used. But we do point out that, in the end, it's always up to the, clinical director, whoever's signing out reports to, actually decide what pieces of evidence should be used and how much weight to give each one. But sort of as an overall recommendation, we put out that we think that these criteria shouldn't be used. And if you're also interested, in addition to our letter coming out, they reached out to the original authors of the ACMG AMP guidelines for a comment back. And they essentially say that they can't say anything. They said that that groups are making, specifications to the ACMG guidelines, including, supporting removal of these, but without having this group reconvene, they can't really endorse or not endorse, this opinion of not using these criteria, which we understand, and we weren't expecting them to endorse it anyway. But yes, you can sort of see both sides of it from the two different responses. Are there any questions about reputable source criteria in general? All right, I will move on then. So a second paper that we had come out recently, I think in December, from SVI is modeling the variant guidelines as a Bayesian classification framework. And I am not a computational person. This is not, I'm not an expertise in this, but I'm going to give kind of a big picture sort of idea as to what this paper meant and like a few interesting takeaways that came from this analysis. So what we did ahead of time was decide what, going to a post-P scale, what would be the different cutoff for like on a scale of 0 to 1, pathogenic, likely benign, and benign. And then anything between likely pathogenic and likely benign would be a VUS. And so this sort of models the idea that likely pathogenic is, your 90% confidence pathogenic, so cutoff of 0.9, but pathogenic being 0.99. And so what we did was, because, looking at the framework, there is those rules for combining, that it sort of has a built-in point value to each piece of evidence of the very strong, moderate. So what we did was try to model those and see if, if each piece of evidence is given a specific weight, how consistent are all the different combining rules as far as reaching the same classifications. So what we did was take each of the combining rules from the paper. So for example, pathogenic 1A, what that means is from the ACMG paper, it was, combining rule 1A, so 1 very strong, 1 strong. Whereas like pathogenic 3A would be pathogenic 3A, one strong and 3 moderates. So going through sort of each one of these different combining rules here and seeing what would be the quantitative scale of evidence to look for pathogenicity. Looking at this sort of now zoomed in more, just looking at this one, what's interesting is we did see that there were 2 combining rules that weren't consistent. For example, one of them is the likely pathogenic rule that you get from 1 very strong and 1 moderate. This is typically, I think people use this combination rule for a loss of function variant that is absent from databases. So based on the ACMG criteria, that gets you a likely pathogenic. But based on the scale of, how much points we're giving to each type of evidence, the number we get at the end, actually, this 0.99 is in the range of pathogenic. So it's interesting because I feel like this is the rule people are most likely to overwrite in general. So it's sort of interesting to see how, consistent or inconsistent the guidelines were. So for the most part, they were consistent. There's just 2 different rules that didn't quite fit in. We haven't yet gone to the point of actually recommending people use these 2 combining rules differently. I think part of that would, go back to talking to the original ACMG AMP group about how intentional some of these combining rules were. Maybe they did really want to limit a loss of function variant that's absent from databases to really only be likely pathogenic as opposed to pathogenic. So there are future things down the road to look at, but this was sort of the takeaway. But another interesting point that came out of this paper that I think sort of is more applicable to everyday assessments is we included as a supplemental file a calculator that allows you to use combined criteria that are not specified in the paper to see what the calculated classification would be. And so this is especially important when you have both pathogenic and benign pieces of evidence, because the guidelines were a bit vague about, how much weight on one side versus the other would push you into a VUS versus allowing you to still call something pathogenic or benign. So I have the supplemental table here that I'll open just to briefly explain what's there. So again, this is the supplemental file from the paper. I'll zoom in. This first section is just going through sort of the same table I showed with all the different rules. And then this bottom part, section 2, is where it allows you to apply different combinations to see what the score would be. So for example, in the guidelines, if you have 1 strong and 2 moderates, that gives you a 0.97, which is in the scale of likely pathogenic. And this is one of the combining rules, 1 strong, 2 moderate, that is likely pathogenic. So that would make sense. But now let's say you have a piece of benign supporting evidence. So if I put it on 1 here, so it lowers it now to a 0.949, which is actually still within the range of likely pathogenic, with the bottom rung of likely pathogenic being a 0.9. But if instead of having a benign supporting piece of evidence, you had a benign strong piece of evidence, let's see if this up, okay, that moves it down to a 0.67. So in those cases, maybe you would want to call a variant, like this benign evidence is strong enough that you would maybe not want to call the variant likely pathogenic anymore, but instead call it a VUS. So this is sort of a first version of being able to help groups kind of weight pathogenic and benign pieces of evidence together to determine what the classification could be. All right. Any questions about that? I realize there's a lot of math and not quite understandable for all, including myself, so I understand that maybe it's not the most straightforward.
So Stephen, this is Christy. This is really cool. So do you foresee our experts using these to try different weights for codes?
Yeah, so I think that, this would help for that, as well as these, combining of pathogenics and benigns to see what you get. So I believe in the VCI right now, within the variant insertion interface, if you have pathogenic and benign evidence, I think it defaults to calling it a VUS conflicting. Yeah, and so this, could be a way that we could, work with them of seeing, what combinations really should have that flag. I mean, I think it's always helpful to know, like, you did have evidence on both sides, but of a way of being able to maybe, like, overwrite or be able to be like, okay, yes, I understand that I had, I only had a piece of benign supporting evidence, like, an in silico assay or in silico prediction say benign, but I have all this evidence for pathogenicity. Does that really need to make me move to a VUS? And the answer, I think, would be no. But I think helping, maybe building some of this into the VCI would be helpful.
Yeah, cool, thanks.
All right, so going back now to sort of more of our more general recommendations of looking at asymmetry criteria. So on the SVI website, the landing page on the ClinGen website, we've been posting the approved criteria, which is from different groups, which at this point is the MY7 group and RASopathy. But then down under this banner is where we've been posting our recommendations as they're finalized. So we had talked with the ClinGen steering committee because we were initially hesitant about putting out recommendations that were not, 100% perfect or, what's the right order of operations, and they decided it was all right for us to put out recommendations that, to not let perfect prevent us from being able to put out recommendations. And so we are going to be versioning each one of the recommendations that come out so that in the future when we do have minor adjustments or, there's different things we want to take into account, we can be versioning these so that, we are keeping up to date and letting people know what's changing. So at this point, the two that are on there, the loss of function de novo are both version 1s, but, there are, still going to be times where these don't quite work with your variants, and, over time it'd be nice to build in some maybe more granular rules about to account for some of the times this won't work, and then we would sort of update and version these recommendations. So looking at our first one, the loss of function criteria. So if you look within the guidelines, loss of function is given very strong piece of evidence, but the guidelines did have these caveats of, being wary of genes where loss of function isn't a known mechanism, when loss of function is at the end of the gene, when maybe instead of having sort of a loss of function, you're just skipping an exon and the rest of the protein is intact, or, multiple transcripts. So we decided to take these different caveats and actually build it into a PVS1 flowchart, so you actually have to address these questions as you're going through variance assessment to actually build in sort of these checks into place. So here's our overall flowchart. I know it's very busy. I'm going to walk through sort of how this works. But generally, what we have is up at the top is where you would start with your variant type. Whether you're looking at a duplication, deletion, splice, frameshift, nonsense, codons. Sort of flow through this chart, and then at the bottom is what strength level you would end up with based off what answers you're looking at. I should note though that as the flowchart stands right now, this is assuming that loss of function is an established mechanism for your gene-disease pairing, and that the gene-disease association is strong or definitive. I'll mention this later, but in the future we're hoping to sort of give better guidance on how to use this flowchart when this is not met, but as the flowchart stands now, this is assuming loss of function is a mechanism. All right, so kind of running out certain areas, I was going to kind of walk through a few of the different variant types. So for intergenic duplications, the main question, or the first sort of question we're asking here is whether or not this duplication is in tandem. There have been some reports that have come out, and I know Amber's working on another paper that I think over 85% of duplications are in tandem. So there's a good chance, even if you don't know if they're in tandem, that they could be. So we sort of break these two cases up for when it is confirmed to be in tandem and you think, and it's going to disrupt the reading frame, that could be very strong, versus in cases where you have not confirmed they're in tandem, but you think that's going to disrupt the reading frame, that could go to very strong. Another caveat we had added to this is to not use if the terminal exon is also known to be included in the duplication, and this could be because you could still end up with a full gene product being made and then have duplication that's just of a few exons that maybe would not disrupt your reading frame or even lead to a viable protein. This is just one of those sort of note we added in. So for example of this type, I took an example that Tina Sarin had sent from P53 group. So looking at P53, they found a duplication of exons 2 through 6. So in the case when you were able to confirm that it is in tandem, you can see that now, your end result is going to be, starting and then getting through exon 6 and then starting again, that this would likely lead to a frame shift and then a non-viable protein. So in this case, because they were actually able to prove that this duplication did occur in tandem, sort of following down this path of, yes, it was confirmed, yes, we think that it would lead to brain disruption, then very strong would be applicable. All right, so now looking at the other side of the flowchart at initiation codons. So we gave these a relatively low weight. So if you have an initiation codon, if it's known, or a change within the initiation codon, we ask you to look where the next closest potential start codon would be, so your next ATG downstream. If there's one or more pathogenic variants between where the natural start is and the next viable start, then you could use this piece of evidence as PBS1 downgraded to a moderate, whereas if there is no known changes there or pathogenic variants there, that you would then want to use this as a supporting piece of evidence. And the reason we were fairly conservative here is because there have been multiple studies that showed that, reinitiation is common for many genes, or being able to use alternate ATG sites, so that even if you were losing your initial start site, that's not actually going to lead to a loss of function type variant.
Can I ask a question about that, Stephen? This is Jenny. So we, in our modification of the guidelines for GAA, and we know for GAA that these initiator codon variants result in production of no protein because patients who are homozygous for those are CRIM negative. So what would we do in that circumstance? Would we still use PBS1 moderate and then include that functional evidence of the CRIM assay for, I think it's PS3, or can we upgrade PBS to PBS1 or maybe PBS1 strong because we know that there's no protein produced? What would be your recommendation?
Yeah, so I'm going to get to those, but I should have qualified before I got to it. As I walk through these, I'm going to explain what this would be with the flowchart as is, but then at the end show some of the examples that we have from working groups where it didn't quite work out and sort of how to account for those, and when maybe a gene-specific rule would come into place that would sort of overwrite what the natural flow would be from this flow chart.
Okay, great. Thank you.
So yeah, Tom, I'll get to that. So for example of an initiation, sorry, I actually took a GA example that Catherine had sent. So they have a variant here within the initial start site that would store this as a start site. The next methionine down is at position 122. Sort of looking at the spin bar track here, you can tell there are multiple pathogenics, which are the reds, within this region from where the next start would be. So with this case, as the rule stands now, PBS1 moderate would be what we would suggest, given that there are some upstream pathogenic variants at the next start site. But as Jenny got into, this maybe wouldn't work for every gene, which I'll mention in a few slides. So now looking at sort of the middle area, because all these ones kind of deal with each other, are looking at the deletions, splice sites, and then nonsense frame shift changes. So the main thing we're looking at here is first whether or not you think there's going to be an out-of-frame or in-frame consequence, and this can come from the deletions or splice sites. And so what we mean here is the exon or exons that are going to be missing divisible by 3? So if that exon size is divisible by 3, then it means that would, losing that exon would not disrupt the reading frame of, for that gene. Whereas if it is out of frame, that is more likely to lead to out of frame consequences and nonsense-mediated decay. However, so in the cases when it is in frame, sort of the next question we ask is whether or not that region that now would be missing is critical for this protein to function. So it could be that, yes, this is an in-frame exon, but this exon encodes a domain that is necessary for the gene to function, so in which case you then could follow down to a PBS1 strong threshold. For the out-of-frame consequences, we then look to whether or not nonsense-mediated decay would be occurring based on if it's, where it is within the gene. If nonsense-mediated decay is predicted to occur, you'd follow down here to this yes, would then ask if this exon is missing from any relevant transcripts, because it could be that you're, looking at a exon that is only within, a transcript that is not biologically relevant, and that exon's missing from all the other biologically relevant transcripts, so then maybe you wouldn't want to apply this criteria at all. But if it's not missing, then you go down and use PVS1 at the very strong level. For cases where nonsense-mediated decay is not occurring, so this could be like a nonsense variant that's in the last exon. The next question asks is, again, going back to this, is this region critical or not? If it is critical, it goes to strong. If you don't know if it's critical or if you think it's a no, you then ask to look within this exon to see, are there maybe more loss of function variants within this exon than any other exon, which would maybe suggest that this exon isn't necessary or biologically relevant. If you don't see an enrichment of loss of function variants within this exon, we then ask sort of what size of the protein would be disrupted, and that would decide the differences between using it at strong or moderate. I have a few examples from some of the groups to show for this middle section as well. So one example that Amanda Thomas had sent for PAH, so this is a -1 splice site within the gene. So I took a screenshot here of this exon. It is a very small exon, but it is out of frame. You can see because it's starting with the beginning of a codon and ends here with a 2, so it's missing that one last nucleotide for this codon. So losing this exon would be predicted to lead to an out of frame consequence. Based on where it is in the gene, it's an exon 6 out of 14. This would be predicted to cause nonsense-mediated decay, and this exon isn't missing from other transcripts, so PVS1, so at the very strong level, would be applicable here. So now another example, sorry, I put this one back in, would be an example that Jesse had sent from the P10 group. So this is a nonsense variant that is in the second to last exon. So this is the last exon and then going into the intron, which I have been cut off, and then the last exon is here. So this variant is at the end of the second to last exon, so it's not predicted to undergo nonsense-mediated decay. However, the group had decided that any truncating variants before codon 375, which is they defined as a critical region, would be, could be pathogenic. And so in this case, going through the flowchart would end up at a PVS1 strong because it's not nonsense-mediated decay, but it's in a critical region. So looking at this again, so here's sort of the big picture. I can't remember. Oh, so as Jesse had brought up before, or Jenny brought up before, times where maybe these won't quite work. So we had reached out to a handful of different disease-specific working groups and asked them to take a set of loss of function type variants and go through the flow chart and see what evidence they would have gotten at the end using this flow chart as is. So in total, I think there are 45 variants that they from the groups in total that were looked at. So for the vast majority, almost 90% of the time, they agreed with what the evidence would be given to that type of variant in the end. For all the times that they were discordant, for the 5 variants that didn't work, the work groups wanted to give the variant a higher evidence level or evidence strength than the flow chart would have. And these all fit into sort of 2 different categories. So one would be, so that in sort of a red arrow for where groups wanted to override is, again, this initiation codon, one of being able to allow this to go up to very strong or maybe even a strong. The other is being able to have variants that land in this truncated or altered region is critical for protein function. And this, you could get to from having a in-frame, deletion of an exon or, a nonsense frame shift variant that is not predicted to undergo nonsense-mediated decay, but it's in a critical region. So like the P10 example, being able to overwrite this answer and having it instead go to very strong instead of strong. So I can't say for positive, what we're going to do yet with these, but when we made this flowchart, we were trying to account for sort of more general approaches to give, people of how to use this for, any random variant that you would be selecting. So I think in cases where in a gene-specific manner, a working group wants to propose for their gene a modification in how this works, I think we will be okay with that because, again, this flowchart was made for sort of more the big picture of everyone that just as how the guidelines are now, it doesn't quite work for every gene. But I think these are probably the two instances that we would probably be most likely to allow for overriding to get to the strength that really the gene group thinks this type of variant should be at. So does that sort of answer your question, Jenny? I can't give a 100% answer without having all SVI weigh in on this, but I think that's what we're going to do.
Yeah, that makes a lot of sense. I do just have another quick question as well. So just to confirm for the splice sites, it sounds like, I mean, purely predicting the consequence based on the number of nucleotides in the exon that you're predicting will be skipped is enough. So you're not too concerned about the possibility of an alternate splice site being used. It really is just prediction based on how many nucleotides are in that skipped exon as to whether it be in or out of frame. You wouldn't look for RT-PCR results or anything like that. It really is just a prediction, right? Okay.
Yeah, so one official caveat, one soon-to-be caveat, I think, for the splice ones is we did add in that when you are using these splice sites, you should be looking at if there are any alternative splice sites within, I think, like 20 base pairs of the splice region to see if maybe there is some, like, a rescue of, oh, it is still going to be spliced, but it's just, 6 nucleotides downstream and keeps the reading frame and thus, wouldn't actually be causing loss of function. The other thing that that we've been talking about possibly adding is an arrow that would go from this in frame to out of frame for when you do have RT-PCR data. So, like, let's say, yes, it is a in-frame exon, but based on RT-PCR data, that actually it's, going to include part of the intron, and that then leads to nonsense-mediated decay, or, it does use an alternative splice site that is then out of frame, allowing this sort of in-frame to go instead to an out-of-frame consequence. And so that is a thing we are proposing of adding in an option here, but we have to bring that back to the full SVI group to look at before we can really add that in.
Okay, great. So in that case, you would be using that functional evidence as part of the deciding what to do with PVS1. So you would then not be able to use the PS3, correct? You would be incorporating that evidence here and not using. Okay, great. Okay, thank you.
Hi, Stephen. I've got a quick question for you on this slide. It's Matt.
Yes.
For the GT, AG, or ATAC, you've just got those two there. It's the canonical splice sites. But there's also, obviously, there's a lot of non-canonical splice sites, in particular GCAG, which I think is actually more common overall than ATAC. So I just wondered, would you give any kind of recommendations to curators on what to do if they found non-canonical splice sites?
Yeah, and this could be, again, in a gene-specific manner, maybe that gene does use more of a different consensus for the majority of exons, and so they want to, include those. This does sort of get back to the versioning, as there are additional types and caveats that we would eventually like to add into splice sites if we wanted to get a first version out. For example, at one point it had also been proposed, if the last nucleotide of the exon went from a G to a non-G, that also has a high likelihood of impacting splicing. So there are some, additional sort of types we want to be able to put in this bucket that I think with time will get added in. We just couldn't get to all of them in time.
Okay, thanks.
Hey, Stephen, this is Christy again. Once you guys finalize this, or maybe it is finalized, I'm not sure, will this be built into the VCI so you could just answer questions instead of, because your flow chart is beautiful, but it might be overwhelming.
Oh, that was kind that you said beautiful, because it is very overwhelming. That is a good question that we could talk with the VCI group of what questions we could add into the VCI to address these. Even if, the first iteration is just like adding in a screenshot of this to the VCI, so at least it's there. Because this version as is, without, the red arrows, it is posted on SVI website now. So this is our, official version 1 of PVS1. That this, I think we could get at least a screenshot maybe, and Matt might have a better answer for that. At least I think that would hopefully be an easy thing to add into the VCI.
Yeah, because a lot of these are yes or no questions, so you could just say, is it predicted to undergo an MD? you know, yes, no, and then that prompts other questions based on your flowchart.
Yeah.
Yeah, I mean, I think we should just...
Is Aaron Riggs on the call? I think so.
Yes, I'm here. Excuse me.
I was just wondering about like the interaction of this with the work we've been doing in the interpretation group. So
yes, Stephen has shared this with me previously, but you know, I was going to ask you offline, Stephen, that you know this is unpublished. So how would you recommend if other groups wanted to reference back to this? Could we at this point, like you said, it's on the website as a version 1. Is that appropriate or inappropriate? And do you plan to publish this and when? And like how might that work?
So we are planning on having this in the human mutation ClinGen issue. This was one of the approved manuscripts. So it will. So yeah, at this point it is. I mean, that flowchart is posted on the SVI website, but yes, it is not published yet, which will, you know, hopefully be coming soon. And we are working through a few modifications to the flowchart that would be hopefully taken into account before we finalize the manuscript and get it submitted. Yeah, so I think for now, pointing to the FBI website to where this works, but soon we would have an actual, like, you know, PubMed ID publication reference to be able to use.
Yeah, that would be great. And so you did say, just make sure I heard that correct, you are planning to put this in the human mutation, right?
Yeah, yep.
And then would you be open to meet, like maybe even just for the website, you know, if we did decide we wanted to just reference people to this, could, you know, at the bottom of yours, you've got PBS 1, strong, blah, blah, which we do not use. Could I suggest like point values for our purposes going along the bottom so that either group could use it?
Sorry, and which group are you talking about?
Variant.
Oh, sorry, you cut out.
Because, you know, we're going to do points and not.
For copy number.
Yes.
Oh, gotcha. Yeah, I think that would make sense. We are going to get us with a few of the other ones. We are trying to move a lot of the rules to more of a quantitative approach, which we didn't quite do here, but that would make sense for a future iteration of being able to put point values on each one of these, because that will allow you to sort of like go between these if you really want something that's sort of between very strong and strong and you're not quite there of being able to, you know, account for that.
And for your the spreadsheet calculator thing that you showed earlier, is it, I know it looked like you had to kind of put in 2 pieces of information and then it would give you a value. But are you able to just put in 1 piece just to go in a stepwise fashion, just to say, like, if I had this 1 piece of information and that is all I knew, like, where approximately how many points would that be worth, or, like, where would that fall?
Yes, it does allow you to do single, yes, the one sort of, yes, so like 1 strong on its own would only get you to a 0.675. I think the 1 minor-ish, this didn't go to 0, is it does on its own allow 1 very strong to go to likely pathogenic, which was not in the combining rules. So that is sort of one caveat, that even though this is likely pathogenic, we do feel like you should have additional pieces of evidence in addition to just a loss of function before you would call something likely pathogenic.
Okay.
But on the point, yes. But for some reason, we're worked out this way with the point system, so it wasn't fully consistent, but yeah.
I was going to say, Stephen, that in our VCI call today, I think it'd be a good place to discuss how we put the, you know, show people the SVI recommendations as they come out. Because we have a process in place for the GCI already that, you know, as the SOP gets updated, we show people, you know, we update, we discuss that on the call. So I think we should do the same thing for the VCI, so we can get these onto the VCI as soon as possible.
Yeah, definitely. I think that would be, yeah, that would be helpful. Right. So as I was mentioning so far, next steps for PBS1 is we do have a manuscript in process that will be in the human mutation issue. some additional things we're going to be looking at in the future is guidance for how you also, the framework as it is right now for PBS1 is, telling you what weight to give, your loss of function variant. But it doesn't really get into how to combine this rule with any other criteria. For example, the functional assays of how these sort of two will fit together of, how much weight can you give both a loss of function variant and a functional assay that's showing its loss of function. Like, is that double counting? Would you knock one of them down a bit so that you aren't giving it too much overall? So we are hoping, and this is, I believe, on the docket for us to talk about at our next in-person meeting of SVI, which will be at ACMG. Another step that we are going to be hopefully adding in is, as the flowchart is right now, this is assuming a strong or definitive gene-disease relationship. But, let's say you were only at a moderate, but there was still some, suspicion or evidence that loss of function is the disease mechanism. How would this work? What we're likely to propose is that you would sort of just knock down the final level by one strength level as a sort of an interim, but we're going to explore this a little bit more to see sort of how to use this flowchart in other instances. Are there any, I think I'm moving to de novo next. Is there any other questions about PBS1? All right, I will move on to de novo then. So the other criteria, the other recommendation we have posted right now is the de novo recommendations. This is PS2 and PM6. So took a screenshot here from the actual ACMG guideline paper about some caveats of when, to be using these de novo criteria. And one thing they do note that we kept within our specifications is that, the phenotype in your patient does need to match the gene-disease association. If you found a de novo variant in a gene, but the phenotype doesn't fit with what you're expecting for that gene, then you shouldn't be using this at all, even though, you do have this de novo occurrence. It could just be, by chance, a random de novo change that is unrelated to the presentation in your patient. So how we have worked through the de novo criteria is we took the two evidence types, PS2, PM6, which I forgot to mention. The difference between these two criteria as they are in the guidelines is whether or not you are confirming both paternity and maternity. Some people have been confused and they thought, confirmed here means you weren't confirming that the parents don't have the variant. In both cases, you are confirming the parents don't have the variant, but the difference is whether or not you are confirming the parents are actually the parents. So how we have worked through the de novo specification is we sort of worked through three different parameters that you would see for your de novo changes. Again, the confirmed versus assumed status, so whether or not you are confirming the parents are the parents, how consistent the phenotype is, and then also the number of de novo observations that you have. So how this sort of looks is we move this to a point-based system, where for each de novo occurrence, you would look through this chart here to decide how many points to assign to that single proband. And then based on how many points you get overall is the overall strength level that you would be using. So for example, if you had a confirmed de novo occurrence in the gene a gene that is highly specific for the gene is 2 points, that gets you just strong, which fits with how PS2 is written for the confirmed de novo in a gene that is specific. So I have some examples to walk through of different types of how we envision this evidence being used. So one example is a patient with early infantile epileptic encephalopathy with a confirmed de novo variant in SIK1. So because this phenotype is not highly specific, this would fit under the phenotype is consistent but not highly specific. And then the points here is going to depend on if it's confirmed or assumed. It's confirmed. So in this case, you would be assigning this patient 1 point, which would then end up at a moderate strength level. So in this case, I think PS2 moderate would be more appropriate than PM6 moderate, but which code you use in the end is not going to matter as much as far as which, the overall strength level between these two. So another example would be So a patient with non-syndromic intellectual disability, but that confirmed de novo in ASHIL. So in this case, this is, the phenotype is consistent with what you'd expect for this gene, but intellectual disability has a high genetic heterogeneity. I mean, hundreds of genes can account for this. So seeing a de novo change within this gene is not highly specific. So in this case, deciding between these two different point systems will again depend on if yours was confirmed or assumed. If it's confirmed, so 0.5 would be the awarded points, and if this was your only proband, you would then use PS2 at a supporting strength level. And then in cases where, so now if you had a patient who had maybe just developmental delay, they had a de novo change in NITBL, they had developmental delay, but no other features of Cornelia de Lange syndrome. In this case, this phenotype would not be consistent with the gene disease association. You would expect other features to be seen. So in this case, no points would be awarded, even though you do have a de novo change, because it does not fit with the expected features for this gene. And this is actually the example that was in the ACMG AMP paper. So for when you would sort of add together, now let's say you had a case where there was a de novo NITBL variant that was seen in 3 unrelated probands. If you saw it once in confirmed state in a patient with Cornelia de Lange syndrome, that would be 2 points because it's phenotype highly specific, confirmed de novo. Now you saw it in a second case, but it was assumed de novo, but they still meet all the features, that's 1 point. And then now in a third case, which also was in an assumed de novo in a patient who met the clinical features. So overall, this would be 4 points. So 2 points from the confirmed and then 1 point from each of the assumed, which would then get you to a very strong strength level for these de novo changes. And so yes, so any questions about how to use these de novo, this idea, and this is also posted on the website, as well as some additional notes and caveats.
Yes.
Sorry, hello?
Did that go through? Hello?
Did you have a question?
Oh, yeah. So my question is about paternity and maternity testing. Do you normally tell that in a paper based on how they tested the patients, such as a whole exome sequencing or just looking at the variant? Is that kind of test what tells you, oh, these are definitely the parents?
Yeah, so that is also something we are hoping to add in better guidance to in the next version of this, of what type of testing would count for confirming versus not. Usually when I'm, just a second, usually when I'm looking at a paper, if they are not explicitly stating it, I tend to go more on the conservative side and call it an assumed de novo if they are not specifically saying that they confirmed that both parents are the parents.
I see, I see. And you have that built into your chart, assumed versus proven, certain,
yeah.
Tested. Got it. Thank you.
Yep, exactly. Yep. Any other questions about de novo? All right, then move on. So the last thing I was going to point out is, as I mentioned before, we are trying to move as much of the criteria to more of a quantitative approach. So sort of next on our docket that we are hopefully going to be finalizing very soon is the PM3 in trans proposal. And this has a similar look to how the de novo specification looked, where based on each proband would be given a certain point value based on if the variant in trans is pathogenic or likely pathogenic, docking down for homozygotes versus if the other allele was maybe a rare VUS, as well as taking into account whether or not phase is confirmed or not, would lead to a point value per proband, and then you would sum all of these up to reach a specific criteria strength level. So this one is still draft, but we hopefully will be finalizing this one and posting it on the website very soon, I hope. So that's all I had there. I just wanted to acknowledge all of the members of SVI as well as the individuals from some of the disease-specific working groups who have sent us different examples to use for PDS1, because those have been really helpful to have as we've been writing the manuscript, but also then as we are explaining, this flow chart to have different types of variants within multiple genes to be able to share and use as examples. So that's all I have, open for any questions that anyone would have about any of these criteria or other SVI questions.
Hey, Stephen, this is Ronak here. This is very useful and remarkable work, and I really appreciate the efforts of SVI team. I just have one suggestion or, one request or that if these point tables and the workflows that you generated as a part of SVI, if it is available for the end user in form of, some web page or service or calculator or something like that, like, user independent of going to interpretation directly, they can use those services just for the calculation, because some of the data is like, people don't like to, easily share before reaching to interpretation. So I strongly feel that, having some independent services that will help you reach about strength of criteria or something like that, that will be very useful.
Yeah, no, that is a good point. Of it is one issue we sort of have is how, every site or lab has sort of implemented the ACMG guidelines differently. So yeah, but it would be good to get ideas from labs as far as how they've implemented the rules so that we can structure our recommendations in such a way that they can more easily adapt these into their own workflows, or if, having a different, more, standalone sort of process would be most helpful for them.
Thanks.
So I guess along those lines, so that the Bayes calculation, it's great that you can do that in the spreadsheet right now, but is there any plan to have that as a sort of online tool or something like that you could just plug the data into easily?
Yeah, I think being able to account for some of this in the BCI would be great, and that's something we can talk about with Matt and Selena to see how easy it would be to sort of account for some of the more common scenarios of if you have pathogenic but then only supporting benign on the other side, should that overwrite? But I guess it would be good to get feedback from the community. When you do have those types of instances, would you still want there to at least be some sort of alert or flag to you in the BCI that you do have evidence on both sides, even if sort of, the Bayes classification would come out of pathogenic? Do you still, want to sort of check off that, yes, I know I still have a benign, but I want to overwrite it? Or how would you want to look at this?
Right. So it sounds like your recommendation at this point would be we should be trying this out. Obviously we're still pretty early days with the GAA recommendations, but I really want to try this out. It looks really cool. But is that what you would be recommending for the groups at this point, to try this out rather than? It seems like such a nice tool. Try it out as part of your pilot study.
Yeah, maybe that could be the next step, is to sort of have like a pilot of, if you have this, to try different combinations of variants where you maybe did have evidence on both sides, and see what you would have called it out as, a group, and what the calculated one will be using the calculator to see how much concordance there is. Like, do we agree in overwriting the same types of scenarios? That actually is a good idea, and I think maybe we will reach out to groups for examples like that.
And Stephen, if I understand correctly, based upon the probability framework that you are using, so if you just have PVS1, it can lead to the weight that is identified as a likely pathogenic. Is that true? If I understand.
So we are not endorsing that yet, no, because again, we do want to make sure there are other types of evidence applied, and sort of requiring there to be other pieces of evidence allows you to sort of like make sure there's nothing conflicting. So even though that is how the Bayes paper sort of came out of that one being likely pathogenic, I don't know if we're going to officially endorse that combination, if that makes sense.
Yes, that's absolutely right. But, PVS1 is a part of several other rules also, right? So it is going to influence other probabilities also.
Yeah, for example, like the very strong with the one moderate based on the Bayes approach comes out as pathogenic, whereas as the rules are, that's only likely pathogenic. And so sort of figuring out the right, we have gone back and forth on what is the right proposal to make to the community about should it sort of be how it is in the ACG paper versus what the quantitative approach was. And it's, every time I bring it up, we get different responses within SVI as far as what is the right approach. And we usually tend to err more on the conservative side just because we don't want to lead to variants being called pathogenic that haven't maybe been as thoroughly reviewed. So